Hello guys, today we will see about dynamic cast in C++. So this dynamic cast can be used only in pointers or references, and that too only with the pointers which are in inheritance hierarchy. That means the casting can be done between a derived pointer to a base pointer, or derived reference to base reference, or base pointer to derived pointer, or base reference to derived reference. So this dynamic cast can be used only in pointers or references, and that too in polymorphic inheritance hierarchy. It can be used only in polymorphic inheritance hierarchy, and that too it can be used only in the class which has virtual function. So if we are converting from one class to another, like base to derived, both should have at least one virtual function. Okay, so these are the conditions. It can be used only in pointer or reference, and it can be used only in inheritance hierarchy. Casting between inheritance of pointers, and it need to have at least one virtual function in it. So here I have defined two class base and derived, and I am having a virtual function fun. So here I am going to use dynamic cast. So I will create two pointers, base and derived. Okay, so previously we have used static cast to cast between base and derived. So when we cast, so initially I am going to cast to base pointer. I am going to cast this derived pointer to base pointer. Here there is no issue. You can use static cast itself because there is no issue. Because this derived will be created from base only. So if we cast to base, there is no issue. So we can use static cast. But I have already told, like, if we try to cast cast this base pointer to derived pointer, then it is not at all safe, because we may not know this base is derived or not. If it is derived, there is no issue, but it is not derived, it will throw, it will cast it here without any issue. But if we try to access any function, it will throw error, runtime error. So let's see what happens here. So there is some compiler issue. Oh, I forgot to provide pointer. Okay, B1, D1. So I'm going to run this program. So if you see, we are getting derived fun10. So I am trying to cast this base pointer to derived pointer. So this is base class created, but I am trying to cast it to derived. So derived, if you see, it is having a member variable j, it won't be created in memory because this B is just a base object. So when we try to call this fun one, it will be called, but whatever on like member variable we are trying to access, it will have some random value, garbage value. So it is printing 0 here. But if we have any complex operation here, our program will crash in our real project. So we should not use the static cast when we try to cast base pointer to derived pointer. So instead we need to check whether this base pointer is really a derived. If it is derived, then we can cast it to derived and then we can use it. So for this purpose only we have dynamic cast. So this dynamic cast. So instead of static cast, I am going to use here dynamic cast. Just only one change. So if you see same statement here, instead of static cast, I am going to use dynamic cast. So this dynamic cast, what it will do is it will check the pointer base pointer. If it is really derived, then it will return the pointer of the object that after casting what is the address it will return. If it is not a derived, then it will return null pointer. So that is the purpose of using dynamic cast. So here we can use if condition if d1 and we can use, so if it is null pointer it will enter else case. If it is having some address, it will enter if condition. So here we can again call fun1. Here we can just print it not derived pointer, like this we can print it. So we can try to run this and see this is base pointer and we are trying to cast it using dynamic pointer. So dynamic cast to derived pointer. So here it has returned a null pointer, that's why it didn't enter this if condition and it has entered else condition. So this way, so this is the purpose of dynamic cast. So this dynamic cast is used in inheritance hierarchy when we are trying to cast base to derived. So that time we may not know this base pointer is actually an object of derived or base. So that time when we try to cast, we will try to cast using static cast. It will cast those uh, that type and it will return. But when we try to call some function or try to access some variable, if it is not actually a derived object, then we will encounter crash. So that's why we need to use dynamic cast and we can ensure if it is really a derived pointer, then we can access the members, or else we can uh, define our own implementation. So this is the purpose of dynamic cast. So I am going to create another variable which is of derived. I am going to dynamic cast to derived this d1. Now this d1 is nothing but this d1 is nothing but a derived object, but it is of base pointer. So I am trying to this b1, I'll declare as b1. So this b1 is of type base, but it is of derived. So I am using the same if condition. Let's see what it is printing. So I'm getting error B1 is redeclaration. Okay, I'm going to use this B2. Oh, okay, in D is also redeclaration, so I will use D2. Okay, this statement here, cout statement. Okay, I'm going to run this now. As if you see here, this B2 is of type base, but it is having an object derived. So now if I do dynamic cast, it is returning a address, valid address. That's why it is entering the if condition and it is calling the fun1 function and printing the 21. So this is the use of dynamic cast. So you can wonder how this dynamic cast is working. So if we have a base class with virtual function, then if we create a pointer or reference, it will store the type of the object we are creating. So that is we will call it as RTTA. So that is runtime information. So runtime type information. So the pointer or reference will have the information of the actual object, and so that the dynamic cast will make use of this RTTA and it will check what is the type. If it is not that whatever we have mentioned here derived, then it will return null, or else it will return the actual address. And this RTTA will be stored only if we have virtual, at least one virtual function in the base. So that is one thing. And if we use that, and if we use the reference, it won't return null here. If we do dynamic cast for reference, it will throw exception, bad cast exception. So I will give you an example. So base, I'm creating a base object base, and I'm creating derived object derived. Sorry, here I am creating reference. No, here I am creating reference. So I am going to assign this reference to derived object. So now if we do dynamic cast, if we try to do dynamic cast of base of this base, then I will get bad cast. Sorry, here also I'm getting redeclaration. Okay, I'll declare D3. So this is derived, that's why it is not throwing any error. I am creating another object base one. So I'm going to cast this. So if you see, I'm getting bad cast exception. So for pointer we'll get null pointer, and for reference we'll get exception, bad cast exception. So this is what dynamic cast means. Thank you.